Hello, everyone. I'm Vincent, and welcome to the first session of speed training we organize here. And this is about Docker ecosystem. This is the track 2 of the Docker speed training. Now, before we start, let me explain a little bit about the content of this training session, and as also why there is 2 tracks for this. So when we prepared this Docker speed training with Casey, we tried to do a little bit of a laundry list of all the features we wanted to talk about Docker, all the histories and everything, and focus on things that are relevant today as of 2024. And eventually, with all this filter, we realized that there was just too much to fill in sessions of a bit more than an hour. This is why we decided to do 2 tracks. So the first track covered by Casey is related to the real Docker architecture, the life cycle of an image, what's happening a little bit under the hood, how to be confident into building an image, running an image, what's actually happening in between an image and a container, all the securities a little bit around to make sure that this process is isolated from another. So if you're still not very familiar with this, I would strongly suggest you start with track 1 from Casey, and then come back here for track 2, which is about the Docker ecosystem. So in here, we're gonna focus a bit more on what is Docker in 2024 so different from Docker 5 or 6 years ago, right? And we'll also covered a few of the dev tools that have been around for quite some time to help you leverage the security, the efficiency of your image, everything related to tools that are gonna enhance your feedback information from your pipelines, right? So without any further ado, let's start. Now, I think that's important to start with a little bit of history, right? Because this will help you understand as to why Docker in 2024 right now is so different from what it used to be even 3 or 4 years ago, right? So here in this timeline, I made it start in 06 or 07 with the contribution of Google to the Linux kernel adding the cgroups. It doesn't mean that before it was not possible to have this kind of isolated process from the machine, right? That's what people often thought about Docker, is that they invented the Docker technology, right? The container technology, I'm sorry. So there is a pre-Docker and an after Docker that allows you to have those kind of like closed box where you can isolate a process from IPC networks and everything. This is not true. Containers have existed for the longest time. There's even like in the 70s or 80s attempt to have such process completely isolated from the rest of the OS and everything. So there's different name about this. You can find, about this called gel, box, you name it. It was not very standardized, but that technology actually existed, right? And this is what allows big companies at that time, like the beginning of Google, IBM, or Amazon, for instance, because at that time there was still, pre-Docker, there was already the cloud, right? Amazon delivered some EC2 to people. You had some S3. Google had tons of data center all around the world. They had to manage tons of machine process and everything, and they were already having that kind of in-house solution to isolate their kind of process instead of building like some anarchy VMs around chassis, right? But it was not standardized at all, and it was very complex. So it was only a very few companies were having the possibility to like have top engineers working on this, and it was kind of the secret sauce, for this company. What Docker changed into this is not so much about the technology per se for the containers, is the democratization of it, right? From one day or another, then suddenly everybody, even personal people on the laptop, were able to leverage this technology to isolate a process from the rest of the machine, right? That's what is the game changer from Docker, right? So Docker released their first GA in March 2013. And I've been fortunate enough to, I've been around at that time, and it was a huge game changer, right? Because as I mentioned, then from one day to another, suddenly everybody was able to leverage this kind of technology. And it had a huge adoption curves very quickly. As you can see that then just a little bit a year after Kubernetes was released, right? So basically Google adapted Borg, which was their kind of orchestration solution, to embed the Docker technology. And just to show you how fast the adoption was, you can notice that in February 2016, on Docker Hub, there was already 2 billion pools of image total from the start of Docker Hub until February 2016, 2 billion pools. And within just a few months after, they more than doubled that number. They had 5 billion pools all around the world for Docker Hub. So this is just to show how fast the adoption and how everybody was eager to leverage that technology, because it was such a game changer. It was not only a game changer from a platform management, right, but from the developments and everything, it impacted the whole supply chains of software, right? You can notice also on that timeline, I put in 2015 that OCI, which is the Open Container Initiative. This is very important. Not people talk a lot about it, but this is actually what drastically changed the standardization of this container technology. So 2015 OCI, it was brought by Docker himself and CoreOS, as well as a few other. Docker gave to OCI the runC, which is the runtime, the little binary for the runtime of a container to OCI. It was overall actually the target of this thing. So it belongs to the Linux Foundation, right? Is to separate Docker, the company, from the container technology as a standardization, right? So it allows other stakeholders to come into the game and have their, I don't know, dev tools, or even their builders of the image, right? So we can mention, for instance, Red Hat, who very rapidly have their own tooling around this. We can mention as well Google with Kiniko, so because it was way too sensitive from these adoption curves and way too dangerous to keep the whole thing into the hand of just one company, right? But Docker play along, right? Because actually they also wanted to survive, right? So either this technology would have completely been repurposed and Docker would have just be the number one, but then would have completely disappeared to this. But so they tag along the games and participated in the OCI, right? So why is this so important to go all around this, and especially the Kubernetes and OCI was mentioning, is that Docker was not the only players around the containerization anymore. So many of the features that were available in Docker's at that times now became more obsolete, right? Even recently, until like, I don't know, I would say 5, 6 years ago, when you would learn Docker, you would spend actually quite some times learning how to mount a volume inside your image, or tweak a little bit of the network settings from your Docker daemon. And those are still very efficient and nice feature, right? In the network, you usually, as a default setting, you would have a bridge, so it could isolate all of the network of the containers that running on a machine, right? But you could also leverage an overlay if you had several machines and a container rocking about. But as of now, especially in 2024, these are not used anymore, right? This is completely being replaced by Kubernetes, which is the orchestration of this, and he's going to manage the volume of the network, for instance. As a personal example, even though I use Docker daily in my work, I haven't had to personally run an image with the specific volumes natively on my machine for years, right? Or even tweak the network settings of my Docker for as much as long, right? So everything is being leveraged by Kubernetes nowadays. So that's why the way we're gonna approach Dockers right now is very different from the way we used to approach Docker even until like 4 years ago. Another thing was mentioning that I keep on saying kind of daily in my several missions is that people are still using Docker Compose. Docker Compose, in my own opinion, should be obsolete. If you are running Docker Compose, that means you have a Docker, and you can change that technology to use Kind, for instance, with Kubernetes in Docker. So I know Compose is nice for your test integration, right? Where you're gonna put a few of the containers, your DB somewhere, your applications and everything, and you're gonna make them talk together and make sure your whole application behaves accordingly to what you want. But you should be using Kind to do this, because Kind does exactly the same thing, but on top of this, you're also gonna test your Kubernetes deployment, right? You can directly deploy your Helm chart within that ephemeral Kubernetes cluster, and you're gonna test the same thing in your integration, but you're gonna test even more, right? And also, the same thing was mentioning as a Docker Compose is that Kind is as code, right? So these ephemeral cluster, you can tear them down and break them up at will, and it's going to be exactly the same configuration every time, right? So if you, in your integration test, still leveraging the use of Docker Compose, you should switch to Kind, right? And if you're curious about this, I did a TZ talk last year about how to use Kubernetes and Docker into your test. And this tool is very robust, right? The history of Kind is that it's actually the ephemeral cluster used locally by the Kubernetes developer to test their development on Kubernetes, right? So it's actually the proper integration test of Kubernetes itself that you can leverage nowadays to have ephemeral container to manage your deployment, right? So why not using it? What we need to takeaways from this couple slide from histories right now is that in my missions, for instance, nowadays I'm reviewing hundreds of PR dailies from large companies. And so I see a lot of Docker files. And it seems that most of them could have been written 5 years ago, right? It feels like people learned Docker at that time, and then they stop leveraging the new features that are around, right? They don't use it at their maximum, right? And I can show you an example, for instance. So let me switch here to France. I think it's over there in optimization. So let me show you these Docker files right there. So these Docker files, is absolutely horrendous. Even this is the kind of Dockerfile I could have seen and could have been good 4 or 5 years ago, right? But there's many things wrong about it, right? So what I suggest you to do is, you have this Dockerfile right now, you can pause the video and watch every single line and thought about everything that goes wrong about this Dockerfile. And trust me, each line has so many things to say about it. But so take your time, pause the video, and look at each lines and see if it's, for instance, exactly like the kind of Docker files you're leveraging in your projects daily, right? And think about everything we could do differently or optimized on that image, right? I'll give you a few. So here we're back. And I thought you took some time to look about this Docker image around here. And I'm not going to go through all of the issue that the Docker image, but I can mention a few right now. That was one of the most important, for instance, is that you can notice this run on root, right? We don't declare any specific user, so that's one thing that's actually very bad. It uses Ubuntu latest, right? So there's two things here. There's the latest, which you should never be using, right? Because you're not controlling the reproducibility of your image, right? If Ubuntu release another major version, then suddenly all your builds get another this new version with new dependencies that might not be compatible with what you have. But also it used the fat Ubuntu image, right? You probably don't need the whole full-fledged Ubuntu to do what you do, right? Now, every major image has a slim version, right? So you can do an Ubuntu Slim that is stripped down all of the unnecessary things you need. You can even switch to Alpine, right? If you're compatible with Muscle C on the C-libs. There's or even distroless, right? Or also, if you, for instance, statically compile everything on Golang and you don't need much of the things, you can start from scratch, right? Your image could just contain the binary itself, and then that's it. Another things here, for instance, we are updating our package cache and we're installing tons of things that might not be needing, right? Do we need Git in our production image? I don't know, right? We're using curl and wget. Probably only need to switch one of the two, right? You can see here on that layer, we are copying everything that is on the context right there. We probably don't want to embed all of the things. There are things that are only there for the development, right, for the toolings, but they definitely shouldn't be in a production image. The organization of the layer is not so good because here you see we copy everything and then we install the dependencies from the requirements.txt, meaning that every time we're going to change a little bit of the file or PI files, right, for our dev, we're going to reinstall the requirements every time, right, because this cache layer on the copy will be invalidating. We are copying here a config.json, and let me show you, for instance, what is the things of the context, right? This, so here, you can see it's a 1 gig files. So we're copying again. We are exposing some port which probably we shouldn't do, right? It's now it's become obsolete also in a way. And well, we'll run a common bash, but we should run like Unicorns or whatever server where you are image running. So there's many things gone wrong in that image that absolutely do not leverage the latest feature that Docker's, and even from a security point of view, this image is very questionable, right? But it still work, right? I can go here, right, and do a Docker. Oops, sorry, Docker build, and still we're gonna call it fat image, and I'm gonna do this. Oh, I had it already in my context, but you can see this build, and this is the kind of image that I see, and it is very typical from the people that learn Docker, I mentioned like 5-6 years ago. and then that's it, right? They start seeing any new features and everything. And this is where I can show you, for instance, a few things that I've changed the way you manage your Docker files. There is, for instance, this very nice features. It's called Docker init. So this one is brand new, right? It got GA'd in February, if I remember. It was available on experimental build for like a year and a half or something, and it evolved a little bit, but now it's become on general availability. It's worth mentioning that these features is only available if you have the Docker desktop installed, right? So you can install it in every platform, right? Mac, Windows, Ubuntu, Linux, you name it. You can install this Docker desktop. But if you only have that Docker Community Edition version, you will not be able to use that feature, right? So let's have a look a little bit into it, right? I'm gonna go through. So I keep on the left part here. I will keep that terrible Python Docker image, and we're gonna try and see how we can actually not write a proper Docker file, but let Docker initialize a template for us, right? So here, as you can see in my folder, I have absolutely nothing, right? It's brand new. See, if I do Docker init, and then it pops up some menu and says, oh, you want to start a Docker project. Nice. Now, which technology are you going to use, right? So for this one, let's say we want a Python image into it. So I choose Python. Which version I want to use? So let's say, yep, 3.10, for instance, is good enough. Which port I'm going to listen to for this server? So let's say 8,000. Yeah, let's go very standard for this. And here it's going to say which command do you want to run. So this is going to be my command on my Dockerfile. So let's change into Python's my wrapper. Yeah, we don't really care so much about this. It's just to see. And then that's it, right? It created all of this file for us. And let's have a look a little bit at what Docker cooked for us. First thing we can see is that the Docker files is a lot more verbose. There's a lot to it into this. But we can notice already a few different things. So it using some arguments, right? So if I want to update and switch to Python 3.11, for instance, then I can use it very elegantly without changing my Docker file. That's just an argument. You can see it's using a slim version, so it's not bloated with all unnecessary things. A few environment variable to this. But one thing worth mentioning is it's creating a user for us. And that user has absolutely no privilege at all, right? It doesn't even have a home. It's got pretty much nothing, right? And another thing that's really interesting and very telling about the way you manage your Docker files in 2024 now is you can see usually in the best practice that you could see around the web and everything, they mentioned that for Python, for instance, don't copy everything and then install your dependencies, which is happening exactly on your left, right? Is try to copy the requirements.txt first, then do your install, then copy everything, right? So you don't invalidate your dependency cache every time you change your Python code, right? But you can do now even better, right? You can see here in this line, we're gonna mount directly into this layer our requirements.txt and even the previous cache that we had in there, right? To run the install of our dependencies. So there's not even that layers that copy the requirements. There is this smart way where instead of copying the files, why don't we just mount it? We save a layer, right? And we directly during the installation. So when we run Python, the pip install or requirements, right? We already leveraging the ones in our context, saving layers, right? Then we declare the user we created just before. We copy then everything, but then we copy it differently, right? Because in here, I'm gonna show you. I'm sorry. Oh, oops. In here, Docker ignore. It's created a Docker ignore just for us. Okay. So it's a very simple Docker ignore. You probably need to add a few things depending on your context of development, right? But at least you start with something, right? Because even though Docker ignore is quite old now, I don't see it quite often into this. And for instance, it's about things, right? Your charts, which is usually embedded, inside your project. You don't need to put this inside your. But if you're using some local dev tools into this in Beam, you don't need to put this inside your Docker image. So all these kind of things that are pretty nice. So let's go back into our Docker files here. You can see it's drastically different, right? And it's not, I would not say production ready. You won't have to use it right this, right? But it's a good start, right? Then you can adapt, from the link down there, you can adapt to your needs. But it's already leveraging the best practice in terms of creating a user, creating a workspace designedly specifically for your applications and everything. And this goes for quite a lot of technology, right? We can have a look, for instance, into which kind of other things we can do, for instance. Let's do some Go, right? So I'm going into Go. Same thing into here. You can notice I've got nothing into imagine, and I'm going to do Docker init. Same thing. I'm going to choose Go, right? Which version I want to use? I want to use 120, for instance. Everything inside my context, whatever. So let's listen to 8000. Oh, I should have init mod this folder to make it look like Go, but here we are, right? And it created a Docker ignore, a Docker files, the composed and readme, right? So let's have a look at the Dockerfile. So same thing as the Python, you can see it's the version is using as an argument. We've got a multi-build stage and even a multi-platform one. We're going to talk about this much later. But it does these very smart things the same way the Python go, right? Every language has this kind of files where you're going to declare all your dependencies, right? So it's going to be the Go mod in Golang, the requirements txt if you're using pip, or, another poetry and everything. You're going to have my project tomls, they say all of this, the package JSON in Node, they all leverage this kind of files where you're going to declare all the dependencies, and instead of copying it, right, you can just mount that file. So here, what we're going to do, we're going to mount the cache that we have already in our modules. We're going to mount the sum and the mod of our files, and we're going to do a download right away. But that things is not in our project, right? So we're not going to invalidate any cache when we are just modifying our Go code, right? It's just our dependencies, and we are saving an extra layer into this, right? So same thing here. We're changing all of this. Then we change an image, same way as before. So this one is using an Alpine, right? So you need to add a few things. You need to make sure we don't have glibc into this, so you need to make sure we're compatible. But you are creating a specific user. The same thing that has absolutely no privilege, can do much. It doesn't even have a home. It's like nothing. And just then after we copy the binary from our build, and that's it, right? Okay. Very briefly, we can go back and do the same thing. For instance, let's call it Java, right? Okay. So here, I've got nothing. If I do Docker init into this, And then I choose Java. So Java for this one doesn't, it assumes you're using a Maven wrapper, okay, to build a Uber jar. If you're using Gradles or other things, but you can start from this and then after that, right? It's just a template for you to have to bootstrap a good start, right? So we're gonna work on our current projects. What version we're using? Let's say we're using 17s. We still want to listen to about 1000s, and then that's it, right? So now let's look at the Docker files he created for us. So here we are on our multi-stage builds. You can see he's moving the wrapper first, right? And the same way he did for the other technology, is not copying the pom.xmls to get your dependency, is mounting it, right? And then it's just going to install your dependencies, right? Then on another stage of the build, right, he's going to build a package out of this, right? Still mounting here the cache, we got it from before, right? And then finally, on our what will be our production image at the end, we just need to create a specific user with absolutely no privilege, and just copying the jar that we build on our target, and then that's it, right? We can even do, for Java, we can even do much better if you're using Spring Boot, for instance, where you can split the jar to then copy, instead of copying the fat jar, which every time you're going to update your code, you'll need to upload everything, copying everything into the image. You can split that jar into having one part of the dependencies into your lib from the bytecode of your application on the other part. And then you copying on 2 layers, right? So you're leveraging the cache for your dependencies, because obviously you're going to update your code much more frequently that you're going to update your pom.xml, right? But that's just the detail. So overall, this is to show you that the way you can see here, those Docker image, those Docker files I showed you are vastly different from the very classic here Docker image that could have been built a few years ago, right? So if you are not using, try to, in your project, to use a Docker init and inspire yourself from this kind of Docker files to up your games a little bit into this, right? Especially that idea of using a mount to mount your dependency files to install them without polluting too much of your Docker image is actually very nice, right? So this was Docker init. I've put the link into there. You should refer to this. The documentation is very nice. Docker is actually having very nice documentation. It's very exhaustive and very accessible, right? They explains a lot of things line by line. They give tons of examples. So do not hesitate to spend some time to read the Docker documentation. You will see that it has some really nice new features to help you leverage and manage the lifecycle of your image. Another things I want to mention, despite Docker init and other things, is managing the secrets during your build, right? Despite Netflix telling a few years ago that love is sharing a password, this is obviously what you should not do, right? And it kind of defeat the purpose of them being secrets, but how to manage them, right? So obviously there is the terrible, terrible way to go, which would be, and I still see it, unfortunately, a few days where people baked their secrets into their projects, and when they do copy files and everything, then they have access to the secrets. But that's very bad. But there are also people that are using, for instance, build arg to pass their secrets, right? So this is a nice attempt. Unfortunately, the build arg persists in the image, right? Even though you don't use them or you try to cover them, there will always be a way for everybody who can access the image to recover that secrets. So you should not be using builds org to pass your secrets. Yet again, I have examples into here. So I think it's inside, yes, that secret. So let's have a look at this Dockerfile, for instance. I'll show you. So it's a from Alpine, right? Latest shouldn't be using it, but that's just for the sake of this very small demonstration. And we declare as an argument these secrets, right? And here we have a layer that says run, we echo doing something with my secret. So you can see the irony of it is that I'm not even using the secret, right? You know, into this. So let's see, I'll keep the Docker files on the left part so you can see, right? And so if I go into secrets, we can see, and let me, just to make sure, oops, in here, let's build that image, right? So in here, you can see Docker build, I'm giving a name, so tag test secrets arg, and I'm passing an argument, right? So secrets that we have in our here was going to be password 123, right? Okay, so we are building that image. Okay, that's very fast, obviously, because there's basically nothing to do in here. But what happened if I do Docker history? So I call it test secrets arg, right? What is it? Oh, sorry for the typo in here. And you can already see it if you're right. Secret equal password 123. So actually, you spoil that secret. Even though you're not using it in your image, right? I'm not doing explicitly calling the value or anything. The value is still in there, right? So if you're building an image like this, passing your secrets, because sometimes, you know, you need to, from inside the image at the build time, connect to a proxy or connect to a private repository to download, you know, some of the Python dependencies, you know, Maven repository, private Maven repository, and many things. And you attempted to pass your credential through an argument at build time for your image is a very bad idea, right? Because even though then after you fill that image, you don't have these secrets anymore inside it. Even if you are putting into a files, you're deleting the files after, it still persists into the metadata and you can access it, which is can be very dangerous, right? So for this, Docker has this feature which is build secrets, and we'll show you how it works into this. So here, instead of having this, what we can do is having this Dockerfile secrets into this, and it's going to leverage that same mount feature we saw for downloading our dependencies, right? It's a mount, but instead of mounting a type bind, which would mount a files into there, we type secrets and then an ID. So this would be the environment variable containing my secrets, right? When I want to build that image. Here it's convenient because the ID would be the same name of the environment variable, but you can change that, right? For some reason, if you want your ID to be different from the value of the variable containing your secrets, you can do so, but it's much more easier to name your ID of the secrets the same way it's the environment variable. And what it's going to do, it's during your build, Docker will mount this value as a file under run secrets, right? With the ID of your secrets. So here, simply what I do is I mount this environment variable contents inside of files, and then I just need to do, for instance, so my token equal the value that we have inside that file, and then I do whatever I want, right? Here I'm exporting this, but I can use it as a credential, so by the goals, you know, whatever you want. But that secrets now is usable within the runtimes and will not persist, right? So in here, so let's move on to this. If I, for instance, build, no, let me, I think I've prepared up in here, yes. directly visible. So in here, so you can see here, I declare my environment variable as a secrets just at the entry bash of my command, right? So I still have my token equal password 123, and then here I'm gonna tell it, instead of build arg, I'm gonna say, hey, I have a secret for you that you're gonna use. Its ID is gonna be my token, and because I don't say anything else about its value, it's gonna assume that there is an environment variable called my tokens that contains the secrets, right? And I tag that image as safe image, and I'm using this Dockerfile, okay? So I'm going to build it. Obviously, it's very fast as well because I'm basically doing nothing with that image. But now if I use Docker history and I call it on safe image in here, you can see that that information that you have here disappeared, right? It does not persist in the image. That's really important. So at runtime during the build, I can access these secrets to, as I mentioned, logging to a private repositories, use some authentication on a proxy, these kind of things. But then once the image is built, I don't have access to these secrets anymore. This is extremely powerful because usually, even though on security right now, the security guys will focus a lot, on vulnerabilities inside the image. We'll see that much later on inside these trainings. But you must start from here first, right? If you don't have any CV in your image, but you're still using build arguments to pass all your secrets inside your image, it kind of defeat the purpose, right? Your image still compromise, your production into this, right? So you should definitely have a look into these two features, right? The Docker init to make sure you bootstrap your image properly, and the building secrets to make sure that the secrets you inject during the build time of your container does not persist inside that image. That's extremely important, right? Another things I wanted to mention on the nice new features you can have with Docker is now Docker is able to build for multi-platform, right? You should use ARM into your, let's say, EKS production cluster, right? No, you have no excuse. For many years, all the managed Kubernetes cluster provided by Amazon, Google's, Azure, you name it, they all offer nodes for your cluster that run on the ARM architecture. And you could have a cost save up to it's just not rare to have a cost save up to 40% on your runtime, right? For the same performance, right? It's just cost 40%, up to 40% less. So you should use it. It was still difficult to use up to 3-4 years ago because many of the big editors that provide image that could be used along to maintain your cluster would not sometimes provide some ARM image, but nowadays all of them does, right? I have a specific example that I remember was 4 years ago in a previous missions where Amazon's GA'd ARM, certain type of ARM runner for their EKS, and we obviously wanted to switch all of our workload onto ARM. But the thing is that, so obviously, to manage a Kubernetes cluster, we'll have a lot of other tools and everything to see for the monitorings, the logging, and everything. And there was, for instance, FluentD that we were using as a daemon set parent that was not available on ARM. That was the only one, right? Everybody else would use were made ARM Docker image available, but FluentD did not, and it would stop us into this. So what we did is basically we rebuild that full FluentD image on an ARM architecture to make sure that we could switch completely all our workload to ARM node and saves quite a lot on our monthly bill for our cloud. But this, you can also do it directly on your laptop, right? So in here, So let me switch to clean things. If I do docker build xls here, you can see all of the architecture that can build Docker image into this machine, right? So obviously AMD 64, right? Few version of them, PPC, right? But you can also see ARM that are here, right? So this is available because also I've installed a few package for emulation of this. So this package is QEMU, right? So for Ubuntu, for instance, you need to install QEMU and QEMU user static, if I remember correctly, but you check the documentation, it's very explicit into this. There's a bit large. There's 200 megs, if I remember correctly, but they allow you to emulate other architectures. So on this machine, which is an AMD, I can build ARM image into this. So obviously, professionally, in your experience, what you would have is like inside your GitHub Actions or GitLab CIs or Jenkins or whatever, you would have specific runner that run natively in that architecture. So then you can build without using emulation. So that would be much faster. But even if you don't have that available, you can still use this emulation to build your Docker image into this proper architecture, right? So if, for instance, I go to, oh, I'm not into this, so cd, whoops, Zenika, but where am I? Normally I don't. Oh, where? Oh, let me switch. Oh, I see. Let me go back to see what's happening. Yeah. Oops. Optimization. We have here. So I think I have an example to this. Yeah, I can do this, for instance. Oops. Go back here. So I'm going to build a terrible Python image into this for ARM. So I'm not going to hide you the fact that it is going to take a while, right? Because this is emulation, right? It's not natively ARM. So by the time it's doing all of the things to build the image, it's going to be quite slow. But still doing, I think the total time for this is like 10 plus minutes last time I did into this. But now I want to say there's kind of like no excuse for you to not leverage ARM technology. It's the same performance for much less, and also it uses less energy, right? So it's a little bit of a green IT in there. The CPUs, they use less voltage for performing the same. So please embrace ARM and try to do some lobby on your platform team, you know, for your productions or whatever. If they use some managed Kubernetes technology, every cloud providers nowadays offers to have the workload run on ARM. You've got tons of different type of machine. It's become the norm nowadays, right? It's become very standard. And kind of a pro tip, if you want, because we're having that multi-platform technology into this, as you see into our building here, instead of having this platform here as an input for our Linux, right, we can use it as an argument, which is pretty nice because inside, if you're using some compile technology like Golang, for instance, you can also directly compile your Go code for that architecture, right? So you don't have to modify different, you have different Docker files for different platform, right? You can all leverage at once and use the platform as an input. So then you can have at once, right? You would compile everything for AMD, then RAM, you know, PPC, whatever, right? You have this technology available even from your laptop, right? So here were those for the kind of like new features or kind of new features we have in Dockerfile that makes the difference and show that using Docker in 2024 is very different from using Docker, let's say in 2017, where we would see most likely the kind of Dockerfile I showed you very before about this terrible Python thing. Now you can do so much more, right? More securely, for more platform, for anything. This is what we should normally see in a 2024 Docker files in every project, right? So now let's talk a little bit about the dev tools around, to help you in your life cycles management for Docker image and containers. The first tool I want to talk about is Dive. So certainly most of you, or many of you, would have at least heard about this tool. It's very famous. It's a staple in the container ecosystem. It's been there for many years, and it's going to help you see the efficiency you have on an image directly from your laptop, which is sometimes a bit cumbersome. So you can see that project here, it's on GitHub, is having close to 50K stars and close to 2K fork. It's, as I mentioned, is really a staple. It's very well known, I think. So let's keep on building our image here. On top of this, oops. To here, let's quit this one. And let's go back to same or optimization, or I don't have to switch over. I've built that fat image, right? That's not very good. So let's test right in live how it looks like with Dive, right? So I've called my image fat image, and I'm just going to do Dive fat image, right? Dive comes as a small CLI. It's written in Go. You can install it, follow their GitHub README very quickly. And so what it's going to do now is, so obviously it's going to fetch the image. You don't have it locally, but we already have. And it's going to show you this, right? So in here, the first thing we saw is on the upper left part, you're going to see all the layers of your image being built, right? So we're building from a certain blobs in here. So this is our Ubuntu. And then you can see here our updates. We were changing our work there. We're copying every files. Then we run that update for dependencies. We're copying our JSON files, right? And also on the left part of the image, you can see the file system of that current layer with different color into this. So obviously from will not going to change, but here we're going to run the update, and you can notice here some directory change color. So that's mean they've been modified. So here in etc, you can see everything that has been modified when I run my image. So I've installed all the dependencies that most likely I may be not needing it, right? Run in here, we've got our user, but here, most importantly, you can see in the var that we have updated the cache of our package manager, and we didn't even clean it, right? Not so good. Then we're copying everything. So in here, we have, where is it? Oh, it's upper or hap, right? We're copying every files. We don't have a Docker in yours, so we copy pretty much everything that we probably don't need as well. And then we run our install. You can see that here you're gonna update your pip cache and everything, right? You can see all of the file layers by layer being copied, modified, or delete. So you can see how the copy and write will make your image much larger than you see, right? And then a metrics that's important to notice will be on the bottom left part of the screens. Here is going to be image efficiency. You can see score 60%. That's very bad. You should at least aim for 95%. Everything that is under 95% is not very good. Like even a 90% efficiency image is not good, right? Over 2 gigs, so this image, right, this oversize of this image is 2.8 gigabytes because of our config files, right? Your config JSON that is 1 gigabytes in there that we copying several times. So the copy and write made it that it's copied on the first layer, then is recopied on the second layers and everything, which lowers a lot of our efficiency, right? And it says you can at least save 2.2 gigabytes in that image by copying that config JSON, but also the cache, right? The cache of the pip, the cache of your package manager and everything, because basically all of your image here, you did some installation, you did some compiles, you did, well, not compiles for Pythons, but you did so many things, but you didn't clean up after, right? So you embed all of those information within your container production image, which is not very good, right? So these tools, very lightweight, is very nice to have on your laptop just to check the efficiency of your image and how you can do better. There is a possibility also to run this in your pipeline, right? Where instead of giving this GUI, you can have it just output and compute that efficiency score. And you could have a hard get, right? Let's say I want in my GitHub Actions output the efficiency after building of my image, and I don't want any image that is lower than 95% efficiency, for instance. And then you drop the build because it would be lower than that score. That's perfectly doable. So that's it for Dive. If you want further information for this, I strongly suggest you go into their GitHub. They've got tons of information for you on how to install it, how to use it, you know, everything's. It is a staple really inside the Docker ecosystem, right? This Dive is very famous, and you should use it, definitely. And then finally, a few more tools for two different kinds of features regarding security. The first one is cosign for signing your image. It's become more and more important now that you sign your Docker image or any OCI artifact that you have, right? Because you can sign also directly your Helm charts and all these kind of things to make sure that your image that you sign is exactly the one running in production, right? You could leverage inside, for instance, if you run on Kubernetes, which I'm sure you do, have an admission controller rules at the entrance of your Kubernetes cluster that will only allow pods to run from signed image, and it will check the signatures of your image every time. And also now every big providers of image, their editors, they sign their image, and you can check that the image that you have in your production is exactly the one intended over there, right? And not only because you run and declare the SHA of your image and not only the version, but let's say, you know, anybody can be compromised right into this and change the SHA or update the image and everything without having to sign, because they can compromise your supply chains and access this, but they cannot access, for instance, the signing and the CA to sign the proper image. Usually you would use your IDC rights to sign, so all of this from the identity. It's not enough to use the SHA of the image to make sure that your image is actually the one that is validated by the editor to say, this is the image that I've signed and that I approve, and I take no responsibility, but this is the image that you want to run, right? This is extremely important because the supply chain of Docker image is a very easy, converted targets by hackers to take controls or compromise your system. It is extremely sensitive and important, right? And an extra layers of protection that you can have to make sure that you're safe on your production environments is to sign your image, right? So cosigns comes also, where is it? into, yeah, this one's, for instance. It's from Six Stores. So Six Stores used by many people around the world, like Google's, all of them, they all use this. This small binary will allow you to sign your image, but also trust and verify the signatures of the image address. It's very easily installed, written in Go as usual. You can install it directly on your laptop very easily. And I'll show you an example, for instance, of verification, right, into this. We finish our ARM build, right? You see there. So it was obviously, it took a little bit longer than a native build, but I was still able to rinse. And so now on my laptop, I have an ARM image that I can use and pull for an ARM workload, right? So here I exit dive, and obviously this had to happen. Let me take this. Okay. So what do I do in here, right? Let me show you and go back up a little bit to this, right? So here I use cosine. I want to verify an image, and the image I want to verify is on the GitHub container registry. It's a Flux CD, so it's the source controller version 100 RC5, and that's I use Flux because it's a project that I'm really fond of, and I really likes. And this is a V1 that's a kind of 2 to 3, more like 3 years old image, right? And I was already signing their image at that time. So I want to check the validity of the image that I would have in my registry here to make sure it's the proper one, right? And in here, I can check that here is the payload with that all the certificates and everything, and then make sure that, yes, this is the proper image from the identity issuer Flux CD. So this is the proper, right? So use this. It doesn't cost much, right? Signing or no signing, it's a bit of like Let's Encrypt when it starts a few years ago, right? Before people say like, oh, if you want to have a certificate from a proper CA, it costs some money. It's cumbersome, but with Let's Encrypt, you could just on demand having exactly what you wanted. This is a bit of the same thing, right? So yet again, I'm going to use that. You have no excuse, but please try and leverage this kind of technology. It has become so much easier now to sign your image and to add an extra layer of protection in your runtime to make sure that the image you run in your production environment is exactly the one that you intended, right? It's really extremely important. And to wrap up and finish this speed training that we have, I wanted to mention Gillet and Sift. These are vulnerability scanning tools. There's tons on the market. So this one are from Ensure, but you can have like Sneaks, Trivi, like there's tons of them. They all do exactly the same thing. So pick and choose the one you prefer. I kind of like Gillet and Sift, so this is the one I'm gonna display right now, or showcase right now. But there's tons of other tools, and they all have their pros and cons, and they literally do, in the end, literally do the same thing. The goal of these tools is, so what we call nowadays a little bit trendy, is the shift left of security. So a few years ago, this kind of security scanning were exclusive to the security department of big companies, where that was not accessible for the developers. And once you build and wanted to release an image, so you've prepared, you've had some snapshots on here, then you're happy with your development, you want to release a version, then you freeze it, you go, and then after you would go to the security department, they would analyze everything, and they would come back at you, oh, this is not possible, you are embedding this and this critical security feature, you need to update, whatever, right? With now those scanning security tools, you can do it right on your laptop, right? You don't have to wait that whole chain, and the feedback loop is very quick, right? As soon as you develop some code, as soon as you are using, for instance, you can you declare your dependency first, right, into either your POM XMLs, your Go mod, your your requirements.txt directly on your laptop while you're running locally that build of Docker image. You can have that feedback that's going to tell you, oh, I'm vulnerable to this kind of version and CVE, and to this I need to update this. This is what we call shifting left, right? It's the feedback loop of information is much faster. So let's dive a little bit into it, and I'm gonna use that same Flux image from 3 years ago, right? And at that time, I didn't copy the whole thing. Oops, here we are. So it's very easy to use, right? I downloaded the Gripe binary, and then I use it Gripe directly. And there's a few more options that you can have, but natively you can do this like this, right? So what it's going to do is going to locally update is DB if the cache is invalidated for getting all the fresh new vulnerability, and scan all your image into this. And you can see there's quite a lot into this. Oh, sorry, yeah, that one there. Up on like mode, there's quite a lot. And what you need to understand that 2 to 3 years ago, that image was clean, right? I would scan it, and that's why it was released at that time. There was nothing into this. Those vulnerability was discovered after, right? And that's what's really important into this, is that it's not because in your pipeline you're scanning your image and you see no vulnerability that will not discover vulnerability like 6 months down the road. That's why I mentioned in my slides in here, when you scan here, you need to scan and rescan and then rescan, and you never stop rescanning, right? Which can be a bit cumbersome, right? Because so let's say what we could think of an architecture to do this is that in your whole company, so there's many projects, they're all building tons of image, downloading tons of image from Docker Hub at their dependencies and everything. And daily or weekly, you would have a cron somewhere on the server that would download all of this image and keeps on rescanning for a whole day long. That can be quite cumbersome, right? What you can do actually is all those images, what they do is they leverage what we call the SBOM, a software bill of material. This is basically a file that's going to list all of the package and dependency and versions and everything that it could find in your Docker image, right? From your which is like, let's say, Alpine or Ubuntu or whatever. So all even the libcs that you have and everything. Then your own dependencies, right? If you're in Java, all the jar you can download, from Spring Boot, from all over there. These files contains the fingerprints of all of it. And then you can use this to scan your actually your image, right? This is much more lightweight. So a good process into what you could do is that in your pipeline, when you build an image, so if you want, you can scan it. Even though you did already scan it in your laptops or whatnot, you can rescan it into your pipelines. But a good thing to do, for instance, would be to extract that software bill of material files from the image you build and upload it somewhere. So let's say you cannot put it as a JSON, right? There's many formats available for this kind of thing, right? But because you cannot put it as a JSON, you can put it in Postgres, in a Mongo, everywhere you see fit to put that kind of files into this. And then that server you're going to use to scan daily, weekly, or whatnot, all the image from your companies doesn't have to pull all those image, right? He can just get those files and do the scan based on these files, which is much more lightweight. You don't have to download all of the things, especially if you have image doing AI or LLM, those very fat image containing many things into this. You only need to get that kind of fingerprint files to scanning. You've got all the information you need, right? And this is what Sift is all about into this. right? So for instance, so we had griped to do the scan, but if we want, we can just use Sift here. And what he's doing, you see, it's because it's basically the same. Sift is part embedded inside Gripe, right? So you can see at the beginning, and it does exactly the same thing, except it doesn't load the database for vulnerability. It's not his job, right? His job is only to output all of the dependencies. You see this one. So Flux is a Go project, right? So every Go modules that is in there, right? You're gonna find all of it with the version, specifically what they are, but you have also the package of the machine, right? It's on Alpine, so you're gonna see all the APKs and everything into this, right? So if you wanna scan that image later on to know, because there's new vulnerability and you wanna make sure the image you built a month ago that you are using in production right now, we didn't discover new vulnerability into this, you can leverage the use of these files only and don't have to download the whole Docker image, right? So here we are for the security. The three little tools, but they do a lot more than just do this. You should definitely embed them into your pipelines and leverage this kind of technology as a reflex for security. So cosign for the signing of your Docker image, and checking also that your dependency image are signed as well. And grep and Sift or many other tools that you prefer for vulnerability scanning. So yet again, you've got Trivy, you've got Snakes, you've got some are open source, some are enterprise version. They come different, but they all do the same thing. They all based on this SBOM file, right? So you can even extract the software bill of material with Sift and use the Northern scanner, right? It's actually not bad things to do to actually use concurrently different scanner, right? Because sometimes the database of vulnerability are not updated at the same time, and depending on the criticity of your workload, right? Better safe than sorry. You might want to leverage the use of a couple tools around there to make sure that the scan is very accurate. And this concludes our Docker speed training